So this is the this is the fourth week, and today we are going to cover these two topics: discrete distribution and continuous distribution. We are going to discuss few problems related to these two types of distribution. So before going to the problem solving session, we will I will go through the formulas of each distribution, standard distributions. So this first is Bernoulli distribution, in which we have a failure rate and a success rate. The probability that x, that our random variable takes the value 0, is 1 minus p, and the probability that x will take the value 1 is equals to p. So there are only two events possible in Bernoulli distribution, and here x equal to 0 is considered as failure and x equal to 1 is considered as success event. Continued on this thread, there is a binomial distribution, which the probability mass function is given by ncx p to the power x into 1 minus p to the power n minus x. This represents that out of n trials we got x success. Okay. Then there is geometric distribution. This geometric distribution, the probability mass function is 1 minus p to the power x minus 1 into p. Here it shows that the first success occur in xth trial. Okay. Then this is fourth one. This is negative binomial distribution, or also known as Pascal distribution. This represents that the rth success in xth trial. Okay, rth number of success happens in the xth trial, and probability mass function is given as using this formula. Here r is a positive integer and p is between 0 to 1. The important distribution is Poisson distribution and uniform distribution. So here Poisson distribution generally used for calculating the number of customers arrived or number of patients arrived or any number of people arrived at any place, like hospital, like banks, like school, college, stations. Okay, so this calculates the total number of customers or passengers arrived at at any place, and the formula is given as the probability mass function is e to the power minus lambda to the power x upon x factorial. Here lambda is the parameter. Okay, so if suppose that we are given that the arrival rate of passenger at any station is distributed according to Poisson distribution with lambda equals to 10 per minute. So this means that in every 1 minute 10 passengers are arriving at the station. Okay, so this is the significance of lambda, the parameter of Poisson distribution. Then there is uniform distribution. So uniform distribution is just like there are total number of, let's say there are total number of n events that can happen, and probability of each event is 1 by n, and it is 0 otherwise. Then there are continuous distribution. So first is uniform continuous distribution, and PDF probability density function is given by 1 upon b minus a, where x varies from a to b. So if we are given a uniform distribution which varies from 1 to 2, this means that fx probability density function is given by 1 upon 2 minus 1, where x belongs to 2 to 1 and 0 otherwise. Then there is exponential distribution, and the probability density function formula is given by lambda e to the power minus lambda x, where x ranges from 0 to infinity and it is 0 otherwise. The mean for exponential distribution is 1 upon lambda. So sometimes and parameter for exponential distribution is lambda. So sometimes we are given this parameter as lambda, and sometimes we are given that mean of the exponential distribution is something this. So the mean is 1 upon parameter, or vice versa. So sometimes we are given the mean of exponential distribution, sometimes we are given the parameter of the exponential distribution. So this is very important to keep this in mind, that parameter is equals to lambda and mean is equals to 1 upon lambda. Then the last is normal distribution, where the probability density function is given by this formula. And to solve the problems, we generally convert this normal distribution to the normal distribution which ranges from which mean is 0 and standard deviation is 1. So we try to convert this any normal distribution. This is any normal distribution with mean mu and standard deviation sigma. So we convert it into normal distribution with 0 mean and 1 standard deviation by using this z equals to x minus mu by sigma. So we will see how to solve these problems, how to solve the problems related to normal distribution. Okay, so we will now try to go through few problems. So first is like assuming that there are assuming the number of years a car will run is exponentially distribution with mean 8. So the exponential distribution, okay, so mean is 8 and it is asked that suppose that Mr. Alok buys a car today, what is the probability that it will run after 3 years? Okay, so let's try to solve this problem. So here we are given the mean is equal to 8 and this is given as an exponential distribution. So we know for exponential distribution mean is 8 which is equals to 1 by lambda, which means lambda value is 1 by 8. Okay, and now we know that probability density function of exponential distribution is e to the power lambda into e to the power minus lambda x. Okay, when x ranges from 0 to infinite and 0 otherwise. Now we are asked what is the probability that x will be greater than equal to 3 or not equal to, it is greater than 3. So we will again see the question. Here it is asked that probability that it will run after 3 years. It will run after 3 years. Okay, so we are seeing here what is the probability that x is greater than 3. So this probability is nothing but 1 minus probability that x is less than equal to 3. And now we can apply this formula, which is lambda e to the power minus lambda x dx, where x ranges from 0 to 3. We know the value of lambda, so we can substitute it, and from here we will get this value is e to the power minus 3 by 8. Okay, so the probability that car will function after 3 years is e to the power minus 3 by 8. Now moving to the next question, it is a student arrives to a bus stop at 6 a.m. sharp. Okay, knowing that the bus will arrive in any moment, uniformly distributed between 6 a.m. and 6:20 a.m. So let's try to understand the question here first. So it is said that at 6 a.m. the student will arrive at station. Student arrive at station. And it is given that the bus will arrive from 6 a.m. to 6:20 a.m. So it can arrive at any time in between 6 to 6:20 a.m. and the distribution of this arrival is uniform distribution. Okay, so now we will try to answer the questions. So we can say that this is uniform, this x is the arrival time of bus, where x is uniform distribution from 6 to 6:20, or we can say it's a uniform distribution of 0 to 20. Okay. Okay. So this is student arrive at station at 6 a.m. It will arrive at 6 a.m. and the bus will arrive in any time between 6 a.m. to 6:20 a.m. Now this let's say that this x represents the arrival time of bus. This x is uniformly distributed from 6 a.m. to 6:20 a.m. or we can say from 0 to 20 minutes. Okay. Because the student is arriving at 6 a.m. so we can consider 6 as a 0 and 6:20 as 20 minutes. Now we will try to answer these questions. So first is the probability that student must wait more than 15 minutes. Okay, so the student arrives at 6 a.m. So the probability that it should wait at least 15 minutes means that the bus arrives after 6:15 a.m. Okay, only then the student will wait at least 15 minutes. So here we are asked what is the probability that x is greater than 15, and this is nothing but probability that x is less than 15. So now we need to find the probability greater than 15. This is nothing but x is less than equal to 15. So this is a uniform distribution from 0 to 20. So we know the PDF is 1 upon b minus a. b is 20 and a is 0. Okay. When x is a to b and it is 0 otherwise. So now this b is 20 and a is 0. So PDF is 1 upon 20 when x is between 20 and 0 otherwise. So this is nothing but 1 upon 20 dx, where x varies from 0 to 15. So this is nothing but 1 minus x by 20, 15 to 0. This is nothing but 1 minus 15 by 20, which is 5 by 20, and it is equals to 1 by 4. Okay. So now we see what is asked in the question. Sorry, I forgot to share this. So here this bus arrive. We are asked in the question that students should wait at least for 15 minutes. So now the student arrives exactly at 6 a.m. So when bus arrives after 6:15 a.m., then only it is possible that student will wait for at least 15 minutes. Okay, so we are asked that the probability of arrival time of bus should be greater than 15, which is nothing but 1 minus probability that x is less than equal to 15. So we try to put the formula here, and this PDF of this uniform distribution is given by 1 upon b minus a, where a and b are the range of uniform distribution. So for this case, b is equals to 20, a is equals to 0. So PDF is nothing but 1 upon 20 when x varies from 0 to 20, and it is 0 otherwise. So here, like probability that x is less than equal to 15 is nothing but this fx is 1 by 20 dx, and x ranges from 0 to 15. It is nothing but 1 minus x by 20 ranges limit from 0 to 15, and this comes out to be 1 by 4 or 5 by 20. So we will try to see what is asked in the question. So here the probability that student must wait more than 15 minutes is 15 by 20. So this is not right. We saw that it is 5 by 20. Now we will check the second option. So the probability that student must wait more than 5 minutes is 15 by 20. So we will check this statement now. So now we are asked what is the probability that x is greater than 5. This is nothing but x is less than 5. So this is nothing but dx by 20, where this ranges from 0 to 5. So 1 minus x by 20, 5 to 0. So 1 minus 5 by 20, which is 15 by 20, or 3 by 4. So we saw that this is 15 by 20. So this second statement is correct, that the probability that a student must wait more than 5 minutes is 15 by 20. Now it is given that if bus has not arrived till 6:10 a.m., the probability that student has to wait at least 5 minutes more is 1 by 2. So what it is saying, that let's suppose that the bus not so if like the student arrives at 6 a.m. but the bus hasn't arrived till 6:10 a.m. Now the probability that student must wait for at least 5 minutes, which means that the bus will arrive after 6:15 a.m. Okay. So now we will find the probability that x is greater than 15, given that x is greater than 10. Okay. This is given that this represents the situation that bus hasn't arrived before 6:10 a.m. and this represents that the student has to wait at least 5 minutes after this event. Okay, it has to wait at least 5 minutes after this event. So this event will end at 6:10. So we will add this 5 minutes into 6 hours and 10 minutes. So this will become 6:15. So that's why we took this 15. So we say that in this question we are asked that probability that x is greater than 15, given that x is greater than 10. So we can write it like this: probability that x is greater than 15 intersection x is greater than 10 upon probability x is greater than 10. So we know that this, if intersection of this is 10, this is 15, intersection of these two events, that x is greater than 10 greater than 15 and x is greater than 10, so intersection is x is greater than 15. So this converges to probability x greater than 15 and denominator will remain the same. So this is nothing but 1 minus probability x is less than equal to 15 and this is probability x is less than equal to 10. So when we use the formula and solve it, it comes out to be 1 by 2. So I forgot to share this tab. So we are asked in this question that probability that x is greater than 15 given that x is greater than 10. Okay. So here it can be written as probability that x is greater than 15 intersection with x greater than 10 divided by probability that x is greater than 10. And this whole numerator will converges to probability x greater than 15 because intersection of two events, and where one event is x is greater than 15 and another event is x is greater than 10, so intersection is nothing but this probability x is greater than 15. So now these can be written as 1 minus probability x less than equal to 15 and 1 minus probability x less than equal to 10, and by putting the formulas we can see that we will get it 1 by 2. So the option B was correct and option C is correct, that if bus has not arrived till 6:10 am, then the probability that student has to wait at least 15 minutes is 1 by 2, is 50%. Okay. Now moving to the next question. So it is given that x is a uniform distribution from 0 to 1. Then we need to find the distribution of y, which is root x. Okay, so we need to find the distribution function of y. So we will see this. Y is equal to root x. Okay, then x is a uniform distribution from 0 to 1. Now probability y equals to I is equals, we can write as root x less than equal to y. Sorry. And this is nothing but x, and where x is less than equal to y square. Okay, now x is a uniform distribution which is varying from 0 to y square dx. So this is nothing but y square. So this is the PDF function is y square, and when we calculate the CDF, this is nothing but differentiation of, this is CDF. The probability that y is less than equal to y, this is CDF. CDF is y square. So probability density function is given as differentiation of CDF, which is nothing but 2y when y ranges from 0 to 1. So this fy is given as 2y when y is ranging from 0 to 1 and 0 otherwise. Because x is ranging from 0 to 1, therefore y will also ranges from 0 to 1 because it is y is equal to root x. So when x is 0, y is 0 for x equal to 0 and y is equal to 1 when x is equal to 1. So therefore y also ranges between 0 to 1, and for 0 to 1 the probability density function for y is 2y and it is 0 otherwise. Now moving to the next question. So an airline knows that 5% of people making reservation on a certain flight will not show up. Okay. Consequently, their policy is to sell 52 tickets for a flight that can hold only 50 passengers. So they know that the passengers who booked the flight, out of those total passengers, 5% of passengers do not show up for their journey. That's why for 50 passengers they book tickets for 52 they books ticket for 52 people for capacity of only 50 passengers. So now assume that passengers come to airport are independent of each other. Then probability that there will be seat for every person who shows up. Okay. So this is a little tricky question. So we know that the 5% of passengers do not show up. Okay, so that's why the airlines books 52 tickets for only 50 seats. Okay, so they for 50 seats they will book 52 tickets. Now we are asked what is the probability that there will be seat for every passenger who is going to arrive. So if the number of passenger arriving at the airport is up to 50, then only it is possible that every person will get a seat, because there are total 50 seats. Okay, so and the arrival of each passenger is independent of each other. So we can say that if a passenger shows up at airport, this can be treated as a success event whose probability is given by P, which is 95% chance. Okay, and the probability that passenger does not show up is treated as failure event, which probability is given by 5%. Okay, here it is given that 5% passengers do not show up. So we consider this as a failure event, and success event is that the passenger will arrive at the airport. So we can see that these two this for every passenger arrival rate is Bernoulli, is distributed according to Bernoulli distribution. Okay, every passenger arrival rate is distributed according to Bernoulli distribution. Okay, where success rate is 95% and failure rate is 5%. Now, huh. Now for all the, let's suppose that total I passengers arrives at airport, and I will range from 0 to 50. It cannot be more than 50, because if it is more than 50, then all the passengers will not get the seat, and we need to find the probability that every passenger arriving at this airport will assign the seat. Okay, so this is only possible when the total passenger arriving at the airport is maximum 50. So let's suppose this is I, this number is I. Now all these i's, all i's are their arrival of all i's are Bernoulli distributed. Are distributed according to Bernoulli distribution, are distributed according to Bernoulli distribution. So sum of all i's will give the so not the sum. So now we are let x presents x is the x is equals to I. Okay, the number of passenger arrives at the airport. So this I is this is sum of I. Okay, no, sorry, this is not sum of I. There are total I passenger which arrives at the airport, and all these passengers, all these i's are distributed according to Bernoulli distribution. So this I is distributed according to binomial distribution, where there is two parameters for binomial distribution, n and p. Here p is equals to the probability that success probability, and success probability here is that they will arrive at the airport, which is 0.95, and n is there are total 52 tickets. Okay, there are n is total number of tickets. Okay, here we are this is total number of tickets, because total number of tickets are 52, and total number of passengers that can and with the capacity is only for 50, capacity is for 50, capacity is 50, and this tickets are 52. So here when we are saying that I is binomially distributed, and for this parameter n we are not considering 50, we are considering 52, because 52 passengers bought the ticket. Okay. So this is not like this I will not be greater than 0. So it is so I is the total number of passengers who will arrive at the airport, and all the i's are distributed according to Bernoulli distribution with success rate of p equals to 0.95. Now this sum of all this is binomially distributed, where n is 52 and p is the success probability, which is 0.95. So I will just explain it in another way. So airplane capacity is 50. Total ticket sold are 52. Success probability that each passenger will arrive, success probability is passenger will arrive or will show up. This is 0.95. Okay. So now we can see that this and all these and let's suppose that all these passenger P1, P2, P3 and P52, there are total 52 passengers who bought the ticket. So all these P1, P2, P3, these all are distributed according to Bernoulli distribution. With p equals to 0.95. Okay. Now let's suppose x represent the number of passengers that arrives at airport. This x is nothing but sum of p1 plus p2 plus p52, and all these are distributed according to Bernoulli distribution. So x is a binomial distribution with parameters n and p. Here this p is nothing but 0.095. This is the success rate, and n here is total number of passengers who bought the ticket, which is 52. Now this is 52. Now the question is the probability that the passengers arriving at the airport is assigned a seat. Okay, the probability that the passengers who are arriving at the airport has assigned a seat, which means, like, let's say total passengers arrives at at airport is equal to I. Now we are asked that this probability x is equals to I, and x is binomially distributed. So this is x equal to I will be 52ci, and where the success probability is 0.95 to the power I into 0.05 to the power 52 minus I. Now this x can be 1, 2, 3. One passenger will arrive, two passenger. Sorry, this I can be 1, 2, 3 up to 50. Because if I equals to 51, then the capacity is only for 50 passengers, so we cannot accommodate 51 passengers. So we want to so the probability that every passenger will assign the seat who arrived at the station is only possible when I ranges from 1 to 50. So if I is 51 and if I is 52, then it is not possible that all the passengers arriving at the station will assign the seat. Then probability for I equals to 51 and for I equals to 52, the probability will be 0. Okay, the probability that every passenger will assign the seat will be 0. But if I is between from 1 to 50, then this formula can be used to calculate the probability. So the probability, the total probability will be, so the total probability probability that passenger arriving at airport are assigned a seat is equals to summation of I equals to 1 to 50, and this is 52, or it can be I 52ci 0.95 to the power I into 0.05 to the power 52 minus I, where I is from 0 to 1. Sorry, it is the possibility that no passenger will arrive, so it will be 0 to 50. I will range from 0 to 50 because for I equals to 1 and I equals to 2, the probability, this probability will become 0 because capacity is only 50. So if there is only 50 seats and if 51 passengers will arrive, then the probability that all the passenger will assign a seat will be 0, because there will be one passenger will left without a seat. Moving to the next question. So this is suppose that the weight of pumpkins are normally distributed with mean 6 kg and standard deviation 2 kg. Then two questions are asked. The fraction of pumpkins weigh at least 10 pound, and second is the fraction of pumpkins weigh between 4 and 8 pounds. So now we will try to solve this question. So the weight of pumpkin, let's say weight of pumpkin is given as x. This x is normally distributed with mean 6 and sigma 2. So we are asked the probability that x at least it should be 10. Or the probability that x is greater than 10, that the pumpkin will weigh higher than 10 kgs. So this is nothing but probability that x is less than equal to 10. Now we can write, we can convert this to a normal distribution with mean 0 and standard deviation 1 by using this z equals to x minus mu by sigma. So x here is 10, mu is 6 and sigma is 2. So this will become, and we denote this as psi function, this will become 10 minus 6 by 2. This is 1 minus psi 2. And we will use this table, this z scale table, to see what is the value of psi 2. So these are the z value, these are negative values, this is positive value. So for z equals to 2.0, this is 0.97725. Okay. So this is nothing but 1 minus 0.97725, which is given as 0.02275. Sorry, this is 0.02275. This is the z value, right? So z value is 2.0. From this table we saw that this is the z scale. The z is 2 point, these are the point quantities. So this, if this comes out to be 2.01, then we have seen this column, but this is 2.0, so we see this first column, and we got this value. We got this value 0.97725, and we put it in this formula, and we got the probability is 0.02275. And the next question is asked that this weighs between 4 pounds to 8 pounds. So this will be nothing but that the probability that x is less than the probability that so in the class it was taught that this can be written as psi 8 minus psi 4. Sorry, not this. Probability that x ranges from 4 to 8. This can be written as 8 minus 6 by 2 minus function 4 minus 6 by 2. This is psi 1 minus psi minus 1. And using this table we will again calculate the function. When z is equal to 1, the probability is 0.84143, and when probability is minus 1, this is given as 0.15866. So we will put these values, which is 0.8413 and this is 0.158387. This comes out to be 0.06826. Okay. So we will see that the fraction that pumpkin weigh at least 10 pound, this is 0.0228, and the fraction that it weighs between 4 to 8 pounds is 0.6826. So option B and C are correct. Moving to the next question. So a reputed publisher claims that in the handbook published by them, misprints occur at the rate 0.0024 per page. in one, there is a probability that the misprint is in one page is 0.0024. So now it is asked that what is the probability that in a randomly chosen handbook of 300 pages, the third misprint will occur after examining 100 pages. So it is asked that the probability of misprint per page is 0.0024, and we are asked that in a 300 pages of handbook, 300 pages of handbook, the third misprint will occur after 100th page. So this looks like something as Rth success in nth trial, in X trial. This is nothing but negative binomial distribution. Okay, with parameters for negative binomial distribution. The parameters are R and P. So here R is 3 and P X is 100. We want third misprint after 100th page. Okay. So this probability can be given as 1 minus probability that the first misprint occur on after 100th page minus the first misprint occur in the second misprint occurred in the after 100th page. Okay, the first misprint occur after 100th page or second misprint occur at 100th page. So okay, so this is the probability that the third misprint happens after 100th page. Okay, so which is 1 minus probability that first misprint happen after 100th page or second misprint happens after 100th page. So we then apply the formula, which is x minus 1 cr minus 1, success rate which is 0.0024 to the power r, and this 1 minus p will be 0.9976 to the power x minus r. This is r1 and this is r2. Point 0024 to the power r2, 0.9976 x minus r2. X is 100, r1 is 1, r2 is 2. So we put this in the formula, we will get this 0.0024 to the power 0, 0.9976 to the power 100 minus 99 C1 0.0024 to the power 1, 0.9976 to the power 99. So solving this, we will get this probability comes out to be 0.9976. So the probability that we will get this third misprint after 100th page is this. So now we will move to the next question. It is given that suppose the number of customers arriving at a store obeys a Poisson distribution with an average of lambda customers per unit time. That is, if y is the number of customers arriving in the interval of length t, then y is a Poisson distribution of lambda t. Suppose that the store opens at time t equals to 0. Let time t equals to 0. Let x be the arrival time of first customer. Show that the x is exponentially distributed with parameter lambda. Okay. So this we are asked this probability that x is greater than t. X is the arrival time of the first customer. So the probability that no arrival in 0 to t time. Okay. This is given by e to the power minus lambda t to the power 0 upon 0 factorial. Okay, that no arrival will happen in 0 to t. Means 0 customers are arriving. So for 0 customer, this x is 0. So lambda t is the it was given that this is the Poisson distribution of lambda t. The number of passengers arriving in the t interval will be Poissonly distributed with lambda t parameter. So that's why we are taking here lambda t as the parameter. So this is nothing but e to the power minus lambda t to the power 0 upon 0 factorial. This is nothing but e to the power minus lambda t. So CDF will be 1 minus e to the power minus lambda t. So this is nothing but an exponential distribution. So hence proved. So now it is given that u is uniformly distributed between 0 to 1 and x is minus log normal 1 minus u. Now show that x is exponentially distributed with parameter 1. So it is given that this u is uniformly distributed between 0 to 1 and this x is nothing but minus log normal 1 minus u. Now the probability that x is less than equal to small x, where we can write this x as minus ln 1 minus u is less than equal to x. This is nothing but ln 1 minus u greater than equals to minus x. Probability 1 minus u greater than equal to e to the power minus x. Probability that this u is less than equal to 1 minus e to the power minus x, and u is uniformly distributed between 0 to 1. Okay, so we can write it, this probability x is equal, this can be written as dx 0 to 1 minus e to the power minus x. Okay, so this is nothing but 1 minus e to the power minus x. Okay, and this is can be seen as a 1 minus e to the lambda into e to the power minus lambda x. So here lambda value is 1. So this is an exponential distribution with parameter 1. Oh shit, I forgot to share this one. So I will start again. So we are given that the uniform distribution is u is uniformly distributed between 0 to 1 and x is given as minus ln 1 minus u. So we find the CDF of x, which is probability x is less than equal to x. This x is minus ln 1 minus u less than equal to small x. This is ln 1 minus u greater than equal to e to the power minus x. No, greater than equals to minus x. Probability 1 minus u is greater than e to the power minus x. Probability u is less than equal to 1 minus e to the power minus x. This u is uniformly distributed between 0 to 1. So this is dx 0 to 1 minus e to the power minus x. So this will come out to be e to the power minus x. This is the CDF. And CDF of exponential distribution is 1 minus lambda e to the power minus lambda x. So if we relate these two terms, we find out that lambda is equals to 1. So this is exponentially distributed with parameter 1. So we just need to prove this thing. Now moving to the next question. So it is given that x is normally distribution with mean 2 and standard deviation 4, and we need to find these all three things, and y is given as 3 minus 2x. So now see, x is normally distribution with mu 2 and sigma 4. This is mu, this is sigma. Y is equals to 3 minus 2x. Okay, now we need to find the probability that x is greater than 1. So this is nothing but probability that x is less than equal to 1. Then we will just put it in the z function. So this is 1 minus 2 by 4. Sorry, 1 minus 1 minus, this is sigma square. This is sigma square. So sigma is 2. So 1 minus 1 by 2. So you will find the value of psi function using the z scale at minus 0.5. So we will see value of psi function at minus 0.5. So at minus 0.5 the value is 0.30854. This is the value. This is 0.15. This is the value 0.30854. So 1 minus 0.3085. This is 0.6915. Okay. Now second is find the probability that y varies from minus 2 to 1. So y is a 3 minus 2x. Now mu for x is 2 and for sigma for x is 2, sigma square. From the definition of mean and variance, we can find that mu of y is nothing but 3 minus 2 mu of x, which is nothing but minus 1. Similarly, sigma y square will be given by, for this function it will be 3 minus 2x. This is be given by 4 sigma x square. Sigma x square is 4. This is nothing but 16. So we can say that y is normally distributed with mean -1 and sigma variance 16. Okay. So now we need to find the probability of y between -2 to 1. This is nothing but psi of 1 minus -1, which is the mean is -1, 16 minus psi -2 minus -1 divided by 16. So this is nothing but what is x minus mu by sigma. Mu is -1, sigma is 4. Sigma square is 16. So when you use this thing, you will get some value. So this will be psi 2 by 4 minus psi minus 1 by 4, 0.5 minus psi minus 0.25. So using the Z chart, we can find these values. So for minus 0.25, it is 0.40129. This is 0.40129. This is minus 0.25. This is 0.005. This is 0.40129. Okay, and for positive 0.5, it is 0.69146. 0.69146. So by subtracting this, we will get this is around something around 0.1, something around 0.1. Now in the next thing, we are asked the probability that x is greater than 2 given that y is less than 1. So this is nothing but probability. So we can convert this y less than 1 into x thing. Y less than 1 can be written as 3 minus 2x less than 1, which is nothing but x greater than 1. So the probability that x greater than 2 given that x is greater than equal to 1 is nothing but probability x greater than 2 intersection event x intersection 1 x greater than 1 divided by probability x greater than 1. So this is that intersection of x greater than 2 and x greater than 1 will be probability x greater than 2. This is x greater than 1. This is nothing but probability x less than equal to 2 divided by 1 minus probability x less than equal to 1. So this probability is, we reduced it by, so 1 minus probability x less than 2, 1 minus probability x less than equal to 1. This is nothing but function 2 minus 2 by 2, 0, 1 minus psi 1 by 2. So this comes out to be around 0.72. This will be the last question. So the GPA of a graduating senior college is normally distributed with mean of 2.7 and standard deviation of 0.5. Now it is said that only 8% of the class will graduate. So we are asked, what is the minimum GPA required to graduate? Okay. So we are given that this GPA score is normally distributed with mean 2.7 and variance 0.25. Okay. Now we are said that only 8% of the class graduate. So we need to find what is the score, what is the GPA score at which student graduates. So we are asked that is the probability that x is greater than equal to m. Let's m is the this minimum score to graduate. Minimum score to graduate. So this is given as only 8% of the people are able to score higher than this m, because only 8% of the class graduated. So only 8% of the class score higher than m, which is the minimum value to graduate. So we can, this x greater than m can be written as probability x less than equal to m. So the probability x less than equal to m is 1 minus 0.08, which is 0.92. So this is m minus 2.7 divided by 0.5, this z will become this, is 0.92. Now from this z scale we will see the corresponding z value for 0.92. So here in this chart we will see that this 0.92 lie between 1.4, 1.40 and 1.41. 0.92 is between these two and it is closer to 0.141. So we will take this value so for the psi m minus 2.7 divided by 0.5 is equals to 0.92. So the corresponding value for 0.92, the corresponding z value for this is 1.4 or 1.41. We can take anything. So this m minus 2.7 divided by 0.5 is equals to 1.4. From here we will get that m is equals to 3.405. So minimum GPA score required to graduate is 3.405. So we have seen that how these distribution can be used to solve the real life problems. Like this is the GPA calculation. Similarly, the probability that all the passenger who arrives at the airport will assign a seat. The probability that how much time the student has to wait at the bus stop for the bus. So all these distribution help us in solving the real life problems. Okay. So I tried to solve the problems with where we can discuss few theoretical questions where we prove that the arrival time of first first arrival of Poisson in the Poisson distribution is exponentially distributed with parameter lambda, and few other theoretical questions where we, if x is a uniform distribution and y is the function of x, then what is the distribution of y? And then again I tried to solve some real life problems using these distributions, so to give a flavor of theoretical questions as well as the practical questions. So for today's session, this is these are the few questions we discussed for today's session. And if you guys have any doubts in solving the questions of the assignment, you can ask in the next class. So I am going to leave the session now.